Welcome to Lesson 4. Today we are going to be simplifying square roots using our knowledge of factors. We'll know we're successful when we can use those knowledge of our factors to simplify square roots that are not perfect squares. Okay, so we're just going to jump right into this lesson with some review of background skills and knowledge, and then get into some examples and exercises. All right, starting us off with part A, building some background knowledge here. It says, what does the square root of 16 equal? What times what equals 16? Well, we should know by heart now that 4 squared equals 16, so our answer is 4. Square root of 16 equals 4. What does 4 times 4 equal? Well, 4 times 4 equals 16. So, does the square root of 16 equal the square root of 4 times 4? Yes, because this does equal 16, right? So they would equal the exact same things. So the answer is yes here. Okay. Moving on to part B. It says, what is the square root of 36 equal? Well, the square root of 36 is 6 because 6 squared is 36. What does 6 times 6 equal? That equals 36. And then it goes on to ask us, does the square root of 36 equal the square root of 6 times 6? It does, and I know this because this inside, 6 times 6 is 36. So the square root of 36 is always going to equal the square root of 36. So the answer is yes. Okay, you guys are probably getting the picture by now. We're going to do a couple more just to reiterate it. What does the square root of 121 equal? 11. What does 11 times 11 equal? 121. Do these equal the same thing? Yes. Just from before, what we've done in A and B, we know that yes, they equal the same thing. So what I'm trying to teach you right now is that you can break your square root apart. Okay? What's the square root of 81? 9. What is 9 times 9? 81. Does this square root equal this square root? It does. Even though this one looks a little different, it's just been broken apart into perfect squares to help us out. So the answer is yes, okay? Moving on to part E and F, this is a little bit different. It says rewrite the square root of 20 using at least one perfect square factor. So our perfect squares, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. You get the picture, right? Those are our perfect squares. So it says use one of those numbers to rewrite this. So we have the square root of 20. We want to rewrite this using factors of 20. So remember, factors are the numbers that make it up. So some factors of 20 are 1 times 20, 2 times 10, but we're looking for numbers that have perfect squares. So do any of these numbers that I've listed so far fit into 20 evenly? Well, definitely 1 does, but that's not really going to change anything. It'll just say 1 times 20, right? And that wouldn't change much at all because we still have our 20. We actually expanded it. Okay, so let's try a different number. Does 4 go into 20 evenly? It does. And is 4 a perfect square? Yes. So 4 times what equals 20? 4 times 5. So these two equal the exact same thing. So I rewrote this using a perfect square. So we're going to be doing this today because eventually we're going to be able to use this perfect square and remove it from our radical to simplify our expression, okay? Let's move over to part F. Asks us to do the same thing. We want to rewrite this expression where it says the square root of 28. We know that 28 is not a perfect square, but we can figure out one that is. Okay, so remember our perfect square is 1 times 1, 1, 2 times 2, 4, 3 times 3, 9. None of those numbers seem to go in except for 4. So 4 times what equals 28? 4 times 7 equals 28. So I rewrote this using a perfect square. And remember that the perfect square I used was this 4 right here. Okay? So this is just some review of background knowledge and kind of getting you started thinking about what we're going to be doing today. Make sure you have this down, and we're going to move into our examples for this lesson. All right, number 1, it says simplify the square root as much as possible. So I'm looking at the square root of 50 and I want to break it down. So I want to break it down into some perfect squares. One perfect square I can think of right off the top of my head is 25, right? That's a perfect square. So this is the same thing. 25 times 2, right? Because 25 times 2 is 50. So I haven't done too much so far. All right. Now I'm looking within this radical symbol, and I'm looking at this number 25. Do I know the square root of 25? What times what is 25? Well, 5 times 5 is 25. So what I can do is I can take this out because I can find the square root of this. So I took it out and I can put it on the outside of my radical symbol. So now this says 5 times the square root of, well, what's left inside? I took that 25 out. What's left inside is just a 2. So I want you to know that we just simplified this square root as much as possible. Okay? We took the square root of 50, we broke it down into the square root of 25 times 2, and then we were able to find the square root of 25 was 5, and we removed it from our radical to the outside. Okay? So that is how we simplified this as much as possible. Moving down to number 2, we're going to do the exact same thing. Okay? It says simplify the square root as much as possible. So I'm thinking of my perfect squares. Again, perfect squares. 1 squared. 1 times 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3, 9. 4 times 4, 16. And you get the picture, right? We're looking for those perfect squares. So do any of those numbers, do any of these numbers go into 28? Because I'm trying to break this up. Yeah, they do. 4 does. 4 times 7 equals 28. Okay? So I've broken it down. The square root of 28 is the same as the square root of 4 times 7, because 4 times 7 is 28. Okay? From there, I'm looking at this 4, because it's a perfect square. What numbers make up 4? 4 is the same as 2 squared, right? So I can move that 2 to the outside of my radical symbol. And so I'm done with this 4. I moved it to the outside because I took the square root of it. What's left inside our radical that we can't take the square root of? 7. And the reason we can't take the square root of 7? We can't break it down into a perfect square. It's already broken down as much as possible. If we do 1 times 7, that does not break down anything, right? So this would be our simplified square root. As much as possible, we have simplified it. And this is our answer. 2 root 7, or 2 times the square root of 7. Okay? So make sure you have this down. This was our first kind of look at our new learning today, and we're going to move forward with a little bit of practice. All right, I know it feels probably like you are jumping right into your practice super early on, but I want you to just go ahead and try to get a taste of how this works. So I want you to break down these square roots as much as possible. And I want you to be looking for perfect squares to do it. Okay? So you're going to have 2 steps here. You're going to break it down into something times something. And then after that, you're going to remove your perfect square from inside your radical. Okay? So take some time right now. Figure out how you can break it down with a perfect square. And let me know what you come up with when you simplify this. I'm going to write off to the side your perfect squares, just so you have them, but you should start memorizing these. All right, by now you should have been able to break down some of these square roots and simplify them. So the first one, I have the square root of 18. Well, I'm looking at my perfect squares over here, all of these numbers. Do any of these numbers factor into 18? Well, 1 does, but that's not going to help us. In fact, 1's never going to help us, guys, so I'm just going to cross this one off our list. Okay? 4 does not go into 18. Does 9 go into 18? Yes. 9 times 2 equals 18. So that's what you should have put there. And from there, we can break it down further because we know that 9 is a perfect square. We can remove this from our radical because we can take the square root of it. The square root of 9 is 3, so we move that to the outside of our radical, and all that's left inside is our 2. So that is the simplified version of the square root of 18. It's the same as 3 root 2, or 3 times the square root of 2. Okay? Moving on to number 2, we have 44. So looking at 44, just starting at the top of my list right up here, will 4 go into 44? Yes, it will. 4 times what equals 44? 4 times 11. This 4 right here, can I break it down and remove it from my square root sign, from my radical? Yeah, 2 times 2 equals 4. So I can remove it. I can take it out. So this becomes 2, because the square root of 4 was 2. So I turned that 4 that was on the inside to a 2 on the outside. Root 11. And 11 is not going to be broken down any further than that. 11 is a prime number. Okay? Moving on to number 3. All right, number 3, I want to break this down a little bit. Well, this number is one I'm not super familiar with, so I don't really know the factors of 169, so I'm going to break out my calculator to help me out. 169. Well, if I do 169 divided by 4, I get a decimal, so that's not going to work. All right, moving on to 9. 169 divided by 9, I get another decimal. Didn't work. 169 divided by 16, I got a decimal again. I know 25 is not going to go into it. I'm going to try 36. 169 divided by 36, didn't get anything. Okay, let's try 49. 169 divided by 49, didn't work as well. Still a decimal. Let's try 64. 169 divided by 64, still a decimal. Let's try 81. 169 divided by 81, I got a decimal again. You guys, I don't think that any of these square roots are going to go into it. So I think I'm just going to have to find the square root of this. So we're really close to 169 towards the bottom. So let's do 13 squared. 13 times 13. Well, did it in my calculator. That equals 169. So this is 13 times 13. And if it's 13 times 13, I know the exact perfect square of this. This answer, I can remove the entire radical sign. My answer is just 13. Okay? Because the square root of 169 is 13. All right, number 4, 75. I'm thinking about this, and I know off the top of my head, 25 goes into 75, right? 25 goes into it 3 times, so this is 25 times 3. And I can break down this 25 because it's a perfect square. This is the same as saying 5 times 5. So I'm going to move that to the outside because the square root of 25 is 5. I keep my radical, and what's left inside is my 3. So hopefully, going through these exercises, watching me and listening to me explain them was able to help you a little bit. Make sure you have your work down. We're going to move into some more examples, and then we'll do some more exercises in just a second. First thing I'm going to do here is write down my perfect squares. I have 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, okay? I have these memorized. You don't have to memorize them just yet, but you should know them if you kind of try to think about them. Okay, I'm going to use those to help me out. First example here, or example 3 here, says break down and simplify the square root of 128. So I'm going to look at my list off to the side and see, do these numbers factor into 128? Is 128 divisible by 4? It is. It is divisible by 4. It goes in 32 times, so I could use that. Is it divisible by 9? No, it's not. That would be a decimal. Is it divisible by 16? It is. It's when we divide 16 into it, we get the number 8. 16 times 8 equals 128. So I could keep going and I want to find like the highest number that goes in, but 16 is pretty big, so I'm just going to use 16, okay? So this is the same as saying 16 times 8, okay? And what I'm going to do now is break down these square roots within it. So 16 is a perfect square, so I'm going to move that to the outside of my radical sign. What's the square root of 16? 4. So this becomes 4 root 8. Just move my 16 out. Now, can I break down that 8 any further? Yeah. 8 is divisible by 4. So this is the same as saying 4 root, instead of an 8 on the inside, I have a 4 times 2, right? So I have 4 times 2 on the inside, and this is a perfect square again. This 4 is a perfect square. What's the square root of 4? 2. So I'm going to move this out, and I'm going to move a 2 on the outside as well. I'm going to continue my work up here. So now I have a 2 and a 4 on the outside of my square root, and I have a 2 on the inside. Okay, the last step to simplify this is to multiply those two numbers that I pulled out. So I pulled out a 2 and a 4. 2 times 4 is 8, and I keep my radical sign. So when I simplify the square root of 128, I get 8 root 2. Okay. Moving on to number 4. Simplify this square root as much as possible. So I want to see what numbers go into this. So one of the easier ones you can always try is 4. 288 divided by 4, I get 72. That's a really big number left over, so I'm going to try 16. 288 divided by 16, I get 18, so 16 works as well. Let's try 36. I got 8, so 36 also works. I think I'm going to work with 36. That's a pretty big number. So square root of 288 is the same as 36 times 8 on the inside. Okay? The first thing I want to do is break down this square root, this perfect square, which was 36, and move it to the outside. So the square root of 36 is 6. So I move that to the outside. Now I just have an 8 on the inside. Well, can I break down 8 even further? Yeah, I can. The square root of 8 is the same as saying the square root of 4 times 2. Okay? From there, can I find the square root of this 4? Yes, and I'm going to move it out. What's the square root of 4? Square root of 4 is 2. So I have a 2 and a 6 on the outside now, and a 2 on the inside. I can't break it down anymore on the inside of my radical, but on the outside, I'm going to multiply these two numbers together. My final answer is 12 on the outside, root 2. So the square root of 288 simplified is 12 root 2. Make sure you get all this work down, and we will move forward. All right, for these exercises, I want you to try them on your own. I want you to give it your best shot. I have written some perfect squares off to the side again for you to reference, but you're going to break these down and do as much as you can in terms of simplifying them. Okay? And then we'll go over them. All right, so this first one, 108, it's divisible by 4. 4 times 27 equals 128. or 108. So I've removed, or I have simplified that to these two numbers. Now I'm going to find the square root of 4 and move it out. Well, the square root of 4 is 2. So I was able to move that out. And now I just have my 27 on the inside. Can I break that down even further? Yeah, 27 is the same as 9 times 3. Okay? From there, I'm going to break down this 9 because this 9, I can find the square root of it and move it to the outside. So I'm moving this in square root of 9 to the outside. The square root of 9 is 3. And I still had that 2 on the outside. Do you remember that? And then the inside, I'm just left with my 3. Okay? The last step to simplifying this is to do 3 times 2, which is 6, and I keep my root 3. So 6 root 3 is my answer here when I've simplified the square root of 108. Okay? Now we're going to move on and do square root of 250. Well, 250 is the same as saying 25 times 10. Okay? And 25 is a perfect root, so I can move this out. This becomes a 5. So all that's left on the inside is a 10. Can I break that down any further? Well, I could do 2 times 5, but neither of those are perfect squares, so it wouldn't really help me out. So my final answer here is 5 root 10. It's as small as I can get it. Okay? Moving on to this next one right here, the square root of 200. I'm going to split this up. I'm going to say that the square root of 200 is the same as 100 times 2. Okay? And 100 is a perfect square. I can remove this from inside of my radical to the outside. The square root of 100 is 10. So that moves to the outside of my radical. All that's left inside is a 2, and I cannot reduce that. So my final answer here is 10 root 2. All right. Moving down one more. Got the super big number, the square root of 504. So 504, it's not divisible by 16. Let's see. But it is divisible by 4. I know that's starting off really small, but I can start there. So I know it's divisible by 4, so I can do 4 times 126, because those two numbers together make up 504. Now I'm going to remove my perfect square. This becomes 2 root 126. Okay? Now if you go through your perfect squares, 126 is not divisible by 4, but it is divisible by 9. So this is the same as saying 9 times 14. Don't forget we have a 2 on the outside. All right. From there, I can find the perfect square of 9. It's a 3, so I'm going to move this to the outside along with my 2 that was already out there. And now all that's left on the inside is 14. 14 is not going to be divisible by a perfect square, so we're going to leave that inside. And the last step we have here is to simplify 3 times 2. 3 times 2 is 6. So my final answer here is 6 root 14. All right, check your work with my work. Ask me questions if you have any questions. And we will move forward with a little bit of closure and then our exit ticket. All right, just to close out this lesson today with our lesson summary, square roots of some non-perfect squares can be simplified using factors. So our factors that we chose today, we wanted them all to be perfect square factors. So that's why we're making that list of 4, 9, 16, 25. Okay? And once we got a perfect square in there, we could remove it from our radical sign to simplify it. So you'll see in this example right here, they started with the square root of 62 or 72. And they said, oh, that's the same as the square root of 36 times 2, because 36 times 2 is 72. From there, they were able to find that 36 has a perfect square, and they removed it to the outside, okay? And then they ended up getting 6 on the outside of the radical, 2 on the inside, and simplified. All right, we're going to move into our exit ticket now. All right, for your exit ticket today, you have 4 questions where you are finding the square root of these 4 things, and you're doing that by simplifying them. I've listed a lot of our perfect squares off to the side, so you want to see if these are factors of any of the numbers off to the left within your radical signs, okay? And you're just going to break it down. So square root of 24 is something times something, and you want to choose one of the numbers off to the side. And you want to see if you can remove anything from within that radical sign, if it's a perfect square. Okay, if you can, then you can remove it and you can simplify your answer. And if not, then your answer might already be as simple as it gets. Okay? Take your time, show your work, do your best, go back and look at our examples if you need help. And yeah, good luck. After this, please complete your daily reflection in Google Classroom.